So this question provides us with a system of equations. Whenever we have a system of equations question, we should be considering the use of elimination as a process to solve that system, or substitution. But typically on the SAT, it's going to be elimination. So the question says, in the given system of equations, P is a constant. So there is my P. If the system has no solution, okay, that is a huge hint, has no solution, what is the value of P? So what does it mean for a system to have no solution? It means that both X and Y eliminate when we're using the process of elimination for solving our system of equations, and the remaining, I'll call it, right, which is just the numbers that remain. So the remaining is not true. And we'll understand what that means in a second. So let's start off with trying to solve this using elimination and seeing if both X and Y will eliminate. So it looks like I have things that are a bit off pace. It looks like I have two Y terms here, which I can combine. I have a Y on the right side here. So I'm going to just clean this up a bit. And let's use a different color so you can follow what I'm doing. So I'm going to add 3/2 y to both sides of this first equation. 3/2 y plus 3/2 y is 6/2 y, which would be equal to 3y. 6/2 equals 3, so this becomes 3y minus 1/4 x equals 2/3, okay? And then for the bottom equation, I want it to be in the same exact order. So I'm going to start off with my positive py. So I'm going to put that under here. And now I want my x term over. So that means I need to, I'll use a different color, bring this 1/2 x over to the right-hand side. In order to do that, I'd have to subtract 1/2 x from both sides. So I would get a minus 1/2 x here with my py. And then I have my 9/2 here, but it has a like term with the 3/2, so I also need to subtract 3/2 from both sides. And 9/2 minus 3/2 is equal to 6/2, which is equal to 3. So this would just be equal to 3. Okay, so the first rule of a system having no solution is that both x and y must eliminate. They must both cross out. So how do I get my x term to cross out? Because I don't know how to get my y term to cross out because I don't know what p is. But I do know how to get my x term to cross out, and I can get that to eliminate by multiplying by negative 1/2. Because if I multiply by negative 1/2, my x term will become a positive 1/4, which allows it to then cross out with my negative 1/4. So my new second equation would say negative 1/2 py plus 1/4 x equals negative 3/2. So then that again allows me to cross out my 1/4 x. Now, again, the way this works is that whatever I multiply by to cross out one of my variables should also automatically cross out the other. So because I know that, that tells me that this negative 1/2 p here has to be equal to, negative 1/2 p must be equal to negative 3. Because if negative 1/2 p were really just negative 3, then it would be able to cancel out with my 3y because I'd have a negative 3y there. Hopefully that makes sense. I need p to be a value that causes negative 1/2 p to equal negative 3 in order for both x and y to eliminate. And that is how, or that is what we'll always see as the case when a system of equations has no solution. So all I really have to do to solve this is to solve this equation here. I can multiply by negative 2. That crosses that out, leaves me with a positive p is equal to positive 6. And therefore the answer here is positive 6. So 6 is my p-value. It allows for both x and y to eliminate. The remaining is not true. Like that ended up not being all that important here because, in fact, if we did that, we would have, I just want to make sure you see it clearly. So I would have 3y minus 1/4 x equals 2/3. And I would have, instead of negative 1/2 py, I'd have negative 3y plus 1/4 x equals negative 3. And that's why this will cross out, this will cross out. I'd have 0 equals whatever this is, and whatever that is not, right, it's not equal to 0. So that's the part that's the remaining is not true. If this said 0 equals 0, we'd have a problem. That would be a system that has infinitely many solutions. But in this case, we have 0 does not equal whatever 2/3 minus 3 is. So that's why correct answer is 6 here.